Hello again. We are still working in Chapter 3. This set of videos will go with Section 3.3, and what we'll do is develop a technique that's going to help us find zeros of polynomial functions. And that technique is synthetic division. It's a really neat way of dividing a polynomial that's going to help us determine if we have a zero of a polynomial function. And that technique will lead us to the factor theorem and the remainder theorem. So let's look at synthetic division. It's a quick method of dividing polynomials when the divisor, that denominator, this part right here, is of the form x minus k. We got to remember to write our polynomials in descending powers before we can use this method. And if a power has been skipped, we have to put a zero in place of it. So if I have a missing term, I need to put a zero in place for those. So let's look at how synthetic division works. We're going to have a box right here. Then we'll have a number in the box and then numbers following the box. The way we place our numbers in a synthetic division problem is this. We're going to look at our divisor, and it's almost like we're setting him equal to 0, and we're using -3 in the box. So if I look at the divisor, then I'm going to take the opposite sign on that divisor. So x plus 3 means in the box I'm going to have a -3. When this polynomial is in descending powers, all we're going to do is write down the coefficients. A coefficient of 2, a coefficient of -7. Why do you think I need a 0 right here? Because the x to the first power was skipped, and I need to put a 0 in place of those missing terms. And then finally, I have the coefficient, the constant here at the end. So opposite sign for the divisor, list all the coefficients and make sure you put a 0 in place for a missing term. Now the procedure is pretty easy. To begin, we always drop this first coefficient down below the line. Now it's just a series of multiplications and additions. So we'll multiply this 3 times this -2 and put that answer right here above the line. -3 times 2 is a -6. That value will then be combined with the one right above it. So a -6 and a -7, those combine to give me a -13. I continue the same process. I'm going to multiply the -3 in the box times the -13 below the line. That answer is going to be placed above the line. So what is -3 times 13? I believe it is 39. And 39 plus 0 is 39. That goes below the line. Now, one more multiplication. -3 times the 39, and we're going to put that number right here. Oh, let me just come on the side. 39 times 3, it's 27. I think it's 117. Yeah, 117. So -3 times 39 is a -117. And when I combine that with my -5, I get a -112. Okay, so I'm going to do that again right here. So remember, we drop the 2. We multiply -3 times 2. Get a -6, and we place that number above the line. We combine those to get a -13 and multiply again. -3 times -13 gave me a 39. Add that to 0. Finally multiply -3 times 39, place that above the line, and combine those to get my result. So now we have to interpret this result. the last number that you get will always be your remainder. So the remainder here is negative 112. The quotient comes from the coefficients to the left of the negative 112. Now, since this polynomial was a third degree polynomial, and I divided it by an x plus 3, the quotient is going to drop down by 1 degree. So this started off as a cubic, but by dividing, it drops down to a square. And now I'm just going to place those variables in the position. So that 2 represents the coefficient on x squared. The negative 13 represents the coefficient on x. The 39 is the constant, and there is my remainder. Let's practice some more. All right, so let's set these guys up for synthetic division. Let's just do the setup first, and then you can pause it and do the division and then check your work. Okay, what number is going to be in the box here? Remember, the box number comes from the divisor. Since it's an x plus 5, we will have a negative 5 in the box. The numerator is in descending powers, so I'll have a 4 on my x squared. Notice it's missing the x term, so I need a 0, and then I have my constant, negative 3. So there is my setup for synthetic division. This box will have a positive 2. Take the opposite sign. And the coefficients will be a 1 on the x to the 4th, negative 1 on x cubed, positive 1 on x squared, negative 1 on x, and then a 2. And you'll notice that they didn't have any missing terms here, so I did not need to put in a 0. 4, 3, 2, 1, constant. And then over here, the box will contain a positive 1/2. My coefficients will be a 4 for the x cubed. There's no x squared, so I need a 0. Negative 5 for the x, and a 2 for the constant. Now, work on doing the synthetic divisions. So check the work that you have there with what I have here and see if you got the same quotient and remainder. Remember, the remainder, is always the very last number. Remainder of 97, a remainder of 12, and a remainder of 0. Then the quotient will always drop by a degree from the original polynomial. So since this was a square, the quotient's going to have to start with a degree less than that, which would be x. And there's 4x minus 20. 4th degree, so that means down here it's going to be a cube, drop by 1. So that'll be a cube, that'll be a square, that'll be an x, and that'll be your constant. We have a cube, so this drops down to a square, then an x, then my constant. I like synthetic division. It's kind of a fun and easy way to divide polynomials. And the interesting thing is when you come up, well, the interesting thing is on the next page. So I'm going to look at the next page before I mention this. Now, I'm going to take these 3 polynomials. I'm going to take this guy, and this guy. Okay, I'm going to take those 3 and write them as functions. So f of x equal 4x squared minus 3, f of x, f of x. So I took those 3 numerators and wrote them as just some functions. And I would like to find some function values. So you know how to do this. To find f of negative 5, that means we put a negative 5 everywhere we have an x. So this would be 4 times negative 5 squared minus 3, which is 4 times 25 minus 3, which is 100 minus 3, which is equal to 97. We saw that number earlier, didn't we? Okay, let's find f of 2. So it would be 2 to the 4th minus 2 to the 3rd plus 2 squared minus 2 plus 2. So 2 to the 4th is 16 minus 2 to the 3rd, which is 8, plus 2 squared, which is 4, minus 2 plus 2. So let's see. I will get an 8 plus 4, which is 12. Uh-oh, we saw that number on the previous page as well. What are you noticing? This function value is actually the remainder from synthetic division that we did on the previous page. So when you divide a polynomial synthetically by a number, the remainder is actually a function value. So, based on what we saw that happened here, f of 1/2, I can assume, is going to be 0. So what are the connections? The connections are, if you're dividing a polynomial by a binomial, whatever number is in that box is whatever number is in that box, if you were to find f of that value, then the answer to that would be the remainder. So the remainder is a function value. And lastly, if you get a remainder of 0, like we saw over here, we have a remainder of 0. When you have a remainder of 0, the number that's in the box, like the 1/2, is actually a 0 of that polynomial function. I love these kind of connections. So if the remainder is 0, then you found a 0 of the polynomial. So very interesting connections that leads us to these two important theorems. The factor theorem says you've got a polynomial f of x, and if f of k, like f of 1/2, is equal to 0, then x minus k is a factor. So x minus 1/2 would have been a factor of that polynomial function. And then we can go backwards and say, if x minus k is a factor, then f of k is equal to 0. These are basically saying the same thing. So in other words, if the polynomial is divided by x minus k and the remainder is 0, then x minus k is a factor of f of x. And we could also say x equal to k is a 0. That's how this information is connected to what we've been doing here in chapter 3, finding zeros. And the remainder theorem basically just says if you've got a polynomial and you divide it by x minus k, then the remainder is a function value, f of k. All right, so let's use, what is up with this? Can I put that down? I don't want to stop the recorder. No, that's what I need to do. All right, sorry guys. Okay, lost that too. Now let's use the remainder theorem. And we want to use it to find a function value. So I want to find p of -2 for this polynomial function p of x. Now, prior to chapter 3, we would just plug in a -2 everywhere we have an x. But let's try the remainder theorem. When you're using the remainder theorem and they give you the value like p of -2, The number that goes in the box is the value that they give you. You don't change the sign here. We only change the sign if I'm given like an x plus 2 or an x minus 3. That's when I change the sign to go in the box. But I don't change the sign when they tell me the exact value they want me to plug in. So let's list our coefficients. 6 for the x to the 5th. I don't have a 4th power, so I need a 0. I have a 3rd power, which is 10. I don't have a 2nd power, so it's going to be 0. I've got an x to the 1st power with a coefficient of 1 and a constant of 1. So the procedure is I'm going to drop my 6 below the line. Negative 2 times 6 would be a negative 12. Then I add that to 0. Negative 2 times negative 12 would be a 24, and I add that to 10. Negative 2 times 34 would be a negative 68, and when I add that to 0, I get a negative 68. Now the negative 2 times the negative 68 gives me 136. If I add that to 1, I get 137. Now 137 times a negative 2 gives me a negative 274. And when I add that to 1, I get a negative 273. So we've done synthetic division, but over here the answer blank says P of negative 2 is equal to what? What are you going to put in that blank? 6, negative 12, negative 2. What does the remainder theorem say? The remainder theorem says that the remainder is your function value. So all I need to record is the remainder because that's my function value. And so for the next one, we're asked to find P of 1. Using this remainder theorem means we're going to put a 1 in the box. We don't change the sign. List our coefficients with the missing zeros. Got to put our missing zeros in. And when we do the synthetic division, we should come up with the remainder of 18, and that remainder is our function value. So I will stop this video here and pick up with the next one. So let me know if you have any questions.